Hello, and welcome to the GOAT LidarLinking course. This video will give you a brief introduction to the two projects, Regular and Fisheye, and describe the kind of work you'll do in these tasks. These are 2D LiDAR linking projects, meaning that our starting point is a set of existing or base annotations that were added in a prior 3D annotation step. You can tell these base annotations from the clock and arrow icon next to their name in the right panel. Unlike in some other LiDAR linking projects, we don't add new annotations for most of the objects you will see in the task, and nor do we adjust the size and position of existing base annotations. Most of the base annotations you see will appear as polygons, like these ones, but in some older tasks, you may see cuboids. These are mostly the same, except for the object direction attribute, which is handled a bit differently. We'll go into more detail about that later in the course and in the project instructions. As for the names Regular and Fisheye, these refer to different types of cameras installed on the self-driving car or ego vehicle. The regular cameras are, well, regular. In contrast, the fisheye cameras appear distorted as they take in a wider angle of view. This is actually the same scene right here. Note large vehicle 42FF here on the right as it appears in the fisheye and then in corresponding regular cameras. Aside from the difference in cameras, these projects are basically the same taxonomy of objects, and same annotation rules. The work you'll be doing in these projects consists of two main types. The first is adding attributes to existing base annotations. You'll notice that some attributes have already been filled out and have a lock icon next to them. These were filled in that previous 3D annotation step and are not editable, so you should focus on the ones that are unlocked. The second piece is adding what are called ignore polygons, indicating parts of the image that the self-driving car should ignore, including any parts of the vehicle itself that appear in the image. You can see here we have added two ignore ego vehicle polygons, one on the left and one on the right. That slice of the ego vehicle may appear in different places depending on which camera you're looking at. Here in the rear-facing left mirror camera, it appears just once. Or as in this forward-facing wide-angle camera, it may not appear at all. These are video annotation tasks, so there are multiple frames. You can use the slider on the bottom to switch between frames, or you can use the square bracket keys to move forward and backward one frame at a time. Let's look at a few attributes quickly. Two that are particularly important in this task are occlusion and truncation. Occlusion represents when an object is blocked from view, partially or completely, by something, either another physical object or a visual occluder like a drop of rain on the camera lens. Here we have said that the white van is 1 to 40% occluded because it is just slightly blocked by the front bumper of this truck. The truck, meanwhile, is truncated, meaning that it is cut off by the edge of the image. And here we have said that it is 76 to 99% truncated. A few other things that you should know as you go into this task. Let me tell you a couple of hotkeys that you might find useful. The first is H, which shows or hides annotations. Next is L, which shows or hides labels. Then there is G, which cycles through color coding based on attributes and other characteristics of the base annotations or annotations in general. You can also click on this paint palette icon to select what you would like to color by. The color by tool can be very helpful when you're checking a task, whether it's your own work or someone else's. For example, I can color by occlusion. Notice that these objects are colored orange for 0%, and this bus is colored yellow for 100%. But that's clearly not right, so I've quickly spotted an error in the task. Finally, you can press E to show or hide the linter panel, and press the button to run the linters. Linters are automated checks that can help you annotate with higher quality. Here, for example, I'm getting a flag that there's a missing ignore ego vehicle polygon in several of these frames. When I click on that object, sure enough, I can see that it only exists in certain frames, but hasn't been added to the rest.